Welcome to LDI 4.21 or 421. In this LDI, we're going to talk a little bit about scatter plots, and in particular about the relationship between an x variable and a y variable, where both those variables are quantitative variables, okay? So the main plot that we use when we have two quantitative variables that we suspect are related to each other is a scatter plot, okay? Now back earlier in this chapter, we saw how to relate to qualitative variables by using a table and other types of plots. There's some homework problems on those. In particular, you can use bar charts and you can use pie charts. But if the two variables are quantitative, then you're going to use a scatter plot, okay? All right, now, each observation is an ordered pair. So you have an observation of x by y, and it's represented as a single point on the plot. Now, if you plot those points and you see a positive linear trend, what we're talking about is that x increased and y increased. In other words, you can think about it this way, as pen here, as x went up. In other words, as x went up, we also know that y went up. Okay, so they both were increasing. All right, well, let's contrast that to a negative linear association. A negative linear association, x increases and y decreases. So as the values of x go up, I'll get the right color, the right pen here, excuse me. As the values of x go up, the values of y would end up going down. Okay. Now, if you don't see any particular trend in a direction, then we would say they're neither positive nor negative, and that there is no linear association. Now, just quick aside before we go on to the next thing. Notice here that we are focusing right now on linear. Okay, do you see this word linear or linearly shows up all across here? And that's because what we're going to work with later on in the text in chapter 13 is what's called linear regression. We're going to look at the representation of the variables, how the variables are related in a linear fashion. Now, there are lots of other types of regression available, but when it comes down to it, they all relate back to the theory or how we do things from a linear regression. So for beginning practitioners, that's the path we go. All right, so let's go to LDI 421, and all they ask us to do is think about the relationship between the two variables and whether you think that there would be a negative linear association, a positive linear association, or no apparent association. Now, answers are going to vary on this. It all depends on how you define things, okay? So, for example, the age in years of a car and its price. Well, if we're thinking the car is brand new, say to its first 10 years, then we would probably say, okay, based upon that, if we assume that a linear model was appropriate for this data, which we're going to go ahead and assume that for here, then a negative linear association is what we're going to assume, okay? Put the right colors in there. All right, now you could throw a little wrench in the works here and say, well, what if you had a 1962 Austin Healey 3000 Mark II? Well, that car would be over 40 years old, but it's actually worth more now than it was when it was brand new. And that's because, it's a classic car and the car prices come back up. But that's not what we're talking about here. We're just going to assume, that what we meant was just your standard brand new car off the lot, what happens to it as time goes on. Okay, number of calories consumed per day and a person's weight. Well, the more calories you eat, your weight should increase, right? And if you don't eat enough food, then your weight will go down. So if you're starving or you don't have enough calories in your diet, your weight goes down. If you have enough calories or more than you need, then your weight will go up. So what that says is that we have positive linear, let's try that again, linear association. All right, and then what about a person's height and their IQ? Okay, well, again, now we need to kind of preface the situation here. Let's assume that everybody in this study is of adult age, okay? If everybody in the study is of adult age, then there would be what? No apparent association. But let's think about it this way. What if we said that there was another variable involved in this? What if we said that the person's age was also allowed to vary? Then a person's height and their IQ could be related. Let's say if we're comparing, say, kindergartners to sixth graders, we would assume that their IQ had increased, as their height increased, okay? But, like I said, it all depends on how you actually preface the thing before you begin. Okay, well, that's the end of this LDI, and we'll see you all back here soon.